All right, so we're going to start a example of how to draw the ray diagrams for convex lenses, or actually all lenses, but we're starting with the convex lens with our object located outside or further away than C, so pretty far away from the lens. Now, one of the things to note with a lens, yes, there is actual refraction happening inside the lens, but we don't have to draw all of that in. We're going to use the center of the lens as basically the point where the light will change direction. So our first incident ray, as always, is going to come in parallel to the primary axis, connecting the tip of our object and terminating at the center of the lens. You can just have that go straight in. Now, the difference between a lens and a mirror is that lenses use both the focal point and the virtual focal point in every drawing, no matter what type of lens it is. But it depends on which order you do them in, depends on whether it's converging or diverging. Since this is converging, the first transmitted ray, or the refracted ray going through the lens, is going to line up the point where it hits the center of the lens with the actual focal point so that the light travels through the focal point, like so. And since it is continuing on, make sure we draw our arrow that it's continuing on, because light is supposed to move through a lens. That's what lenses do. The second incident ray, instead of aiming at the actual focal point, is going to aim at the virtual focal point. So this time we're going to aim the tip, the focal point, and line it up to the center of the lens, drawing it and terminating right at the center. It's going into, it's an incident ray, so we have it going in, and where it enters diagonally, it's going to exit horizontally, and we've got it right about here. It's going to continue on. Now, the transmitted rays actually meet. Where the incident rays started was the tip of our object, which means our image is going to appear where our refracted or transmitted rays meet. So that's the tip of our image arrow, and then it goes up to our primary axis. The image location is going to be beyond the lens or behind the lens, which is what you would expect light to do, go past a lens or through a lens. The image orientation is inverted. It's upside down because the light is actually meeting. That makes it a real image. And it's pretty easy to tell that this thing is smaller than our initial object. Why don't you try the next one on your own?